Okay, so today I'm going to show you how you can use polyval and polyfit functions available in the MATLAB to fit your data and interpolate. This is our question. We have this weird looking mathematical expression which does not look like linear, but it is linear. We'll see how. And this is the data that we need to fit. Okay, let me show you why I'm saying that this weird expression is linear. Well, the expression is alpha naught km s cube over k plus s cube, right? All you need to do is invert it and do some mathematical arrangement. That's it. 1 over alpha naught becomes k plus k, oops, just k plus s cube over km times k of s cube. Okay, and then k over km s cube plus s cube over km times s cube. So these two will cancel out, and what you are left with is 1 over alpha naught k over km and 1 over s cube plus, I'm so sorry about my writing style, let's just say 1 over km. So this is our y equal mx plus c kind of equation. If you say this is your intercept and this is your slope k over km, and this is your y, this is your x. Let me write that. Y is 1 over alpha naught, x is 1 over s cube, and slope is k over km, intercept is 1 over km. So this is mathematics. Now you can see all you need is take that s and alpha naught value, calculate y and x, and then we are gonna use this polyfit function. So how this polyfit function in MATLAB works? Well, you write polyfit first, and then it accepts some arguments like the data that you want to fit, you need to provide it. So first you need to provide the x data and then y data, and then the order to which you want to fit it. So for example, you want to fit linear, you'll write 1. If you want to fit a quadratic in a quadratic equation, you would write 2, and for cubic that would be 3, right? And for example, because we want a linear equation which kind of looks like this, right? So this polyfit, it will return us basically these two coefficients, fit the data and return these two coefficients, which we can store in some variable called coefficient. And yeah, this coefficient, whatever we get, will be stored in coefficient in the first place. So basically this is how in the coefficient we'll get these two data, and the first element that we get in the coefficient, it has to be the slope, right, which we can equate to k over km, and the second one, which has to be intercept, that can be equated to 1 over km. So that's how we can calculate basically k and km, which is required in this question. Okay, let me take you to the MATLAB. Clear, so you'll see, oh yeah, edit, create a file, I'm gonna call it linear fit. Okay, now first of all, I'm gonna have to input some data, the value of s and the value of alpha. Let's just copy those two values. Copy, paste, oops, okay, and now I'm gonna copy paste alpha values. we have the s and alpha. We need to calculate x and y. Our x is 1 over s cube, 1 over s cube. Make sure that you do element wise operation because s and alpha both are vectors, not just a value, and our y value is 1 over alpha. Okay, now that we have x and y, we can use this polyfit function, and store the coefficients in coefficient variable. Polyfit x and y data in first order. Okay, let's just see. Yeah, it ran successfully, and you see this is 1 cross 2. That means it holds two values. One has to be slope and the other one has to be intercept, right? Okay, so we have slope equal to, the first element is slope and it has to be k over km, and the second one is 1 over km. Okay, so the intercept is second element and slope is first element. So from intercept we can calculate km value, right? Km is basically 1 over intercept, and then using that intercept, once you know km, you can calculate k by multiplying km and slope. You can see k equals basically your slope multiplied with km, and km you have already calculated by taking inverse of your intercept, right? Okay, so what we need is k, and that has to be equal to slope times km. That's pretty good. Okay, and then we can display these two values in a nice looking way. Let's just say the k is, since my k value is a numeric value and display has to handle here the string, what I'm gonna have to do is convert that number k into a string and concatenate it with the string. So to convert that number into a string, we need num2 string function, and what is the number? K. That's what we are gonna convert into a string. Okay, and then display, let's just copy paste, that seems easier, and then just change the value km and km. This is it. Okay, so it calculated k and km. Now what we'll do is we'll use polyval function to interpolate some data of y at x. So this is how polyval works. Polyval. This polyval, it needs the coefficients of the quadratic. Okay, so in our case we don't have quadratic. What we have is a linear expression, and the coefficients are a0 and a1, which are stored in coefficients. So I'm gonna pass coefficient, and then the value of x at which I want to calculate the y value. Okay, so maybe some x new, which will give me some y new. So at this x I want to interpolate the value of y. This is how you would write expression. Okay, so now y new is polyval coefficients, pass it, and then the x value at which I want to calculate my y value, right? Let's just say we already know that x equal to 1 million or y has to be 1.64 whatever it is. So let me give x value as 1 million. 3, 2, 5 and 6, right? And let's just see what is y. Okay, it works. You see, at given x value 1 million, the y is calculated 1.64 here. Okay, maybe I want to calculate y new at 4500. Maybe I can do that. You see, so yeah, that's how polyfit and polyval functions are used.